All right, so we're going to start on sampling and surveys. How trustful are survey results? So after today, anytime you hear results from a survey on the news or in the newspaper or in a conversation, I heard that 41% of whatever, I want you to always question it. Okay, and here's why. The National Highway Traffic Safety Administration reports that seatbelt use in passenger vehicles increased from 84% in 2011 to 86% in 2012. Okay, here's another one. A recent study suggests that the lack of sleep increases the risk of catching a cold. What would you want to know about these studies to make you decide how much you should believe them or not? What information would you want? Who did they ask? Not just who did they ask, which is really good, but where did they ask them? How old? Why did they ask them? How did they ask them? What were the circumstances that they asked them under? Lots of, what do we call that? Confounding factors, yes. Lots of confounding factors. Okay, so let's talk about a population versus a sample. Population is the entire group of individuals we want information about. A census, have you ever heard of a census before? So a census collects data from every individual in the population. Tell me what you know about a census. How do they do it? How do they take a census? They mail it to every household. What's the flaw in that? Some people don't have households. There may be 20 people in that household. Some people don't send it back. They do a census, I think it's every 10 years? Every 10 years. But again, you're not reaching homeless people in shelters. You're not reaching people who are in college. You're not reaching people who are overseas in the military. So there are lots of people that you're not reaching. Plus, you've got a whole bunch of people who just say forget it and they throw it in the trash can. So the data that they're getting back about average income, average highest level of education, all this, how many people are living in your house, how many cars do you have, what's your house worth, all this information is only coming from those people, number one, that you reached, and number two, that are going to take the time to fill it out and send it back. So it's not good data. But a census collects data from every individual in the population. A sample is a subset of individuals in the population from which we can actually collect data. So instead of saying, I want to find out if the students at South Stokes like smiley face fries or regular fries. So would it make sense for me to go and find every single student and ask them? Like, is that feasible? Could I do it? We're a school of 500. That's not awful. But there are schools that are 3,000 students. Would that be a smart thing to go do, to go ask every single person? No. So I could take a sample. What would be a good way to take a sample? Out of each class, so each grade level, so do a sample. How would you pick which ones you're taking? You want it to be random? So would it be smart for them to come to all the AP classes? Would it be smart to come to all the first periods? Why would that not be good? Some people aren't here first period, they have internship, or they sleep in. There are lots of tardies first period. Would it be smart to do it right after lunch? What if there was a bad batch of smiley face fries that day? And people are all kinds of ticked off because they got excited about their smiley face fries, and then they were awful, and then I'm going to ask you, hey, do you like smiley face or regular? Regular. Smiley face fries are terrible. Normally they're really good, but on that day they weren't good. So you have to be very careful about how you get your sample. All right, so let's talk about being able to identify the population in the sample. A furniture maker buys hardwood in large batches. The supplier is supposed to dry the wood before shipping. Wood that isn't dry won't hold its size and shape. The furniture maker chooses 5 pieces of wood from each batch and tests their moisture content. If any piece exceeds 12% moisture content, the entire batch is sent back. What's your population? And you need to be crazy detail oriented here. What is your population? What do y'all think? I have all of the pieces of hardwood in the batch because I'm taking a sample from the batch, right? And that sample is going to help me make a call on that particular batch. So my population, all pieces of hardwood in the batch. What's my sample? Mm-hmm. The 5 pieces selected from each batch. Or if you're just talking about one particular batch, the 5 pieces selected from that batch. Okay, now just to sort of foreshadow into what else we're going to talk about today, how would you get those 5 pieces? Would you take 5 pieces right off the top? Why would that be bad? Yeah, so it's not random. What if the guy knows you're going to do this and he puts his driest 5 pieces on top? Or what if the batch sat out in the rain and those 5 pieces got rained on, but everything else is okay? So it could go either way. So it needs to be random. Okay, each week the Gallup Poll questions a sample of about 1,500 adult U.S. residents to determine the national opinion on a wide variety of issues. What is your population? All. Yep. I love that word all. When you're talking about population, I love the word all. U.S. What else? Not just U.S. residents. Adult. All U.S. adult residents. Not just residents, like they're not going to come ask Sydney. It's just all U.S. adult residents. Okay, what's your sample? The 1,500 U.S. adult residents selected. Now, if this is a phone survey, are they going to get information from all 1,500? So would your sample be all 1,500? It'd be all 1,500 that they reach. What if this was a mail-in survey? Would your sample be all 1,500? It would be all of the 1,500 who not just receive it, but respond. Yep. Okay, so we're going to talk about how to sample badly. A convenient sample. Choosing individuals from the population who are easy to reach produces unrepresentative data. Example, suppose we want to know how long students at a large high school spent doing homework last week. We go to the library and ask the first 30 students we see about their homework time. It's unlikely that this convenience sample accurately represents the homework habits of all students at the high school. In fact, and this is a great sentence right here, it's probably overestimating. Why? Because students who hang out in the library tend to be more studious. So it's not just saying that it's bad, but it's saying which way is it going to swing the vote. Does that make sense? Tell me why it's bad, and then tell me why it's going to swing, which way it's going to swing. It's going to overestimate, probably. Why is this called a convenience survey? In one spot. I'm going to one spot. I'm grabbing the first 30 people. It's convenient to me. Okay? This is bias. Using a method that favors some outcomes over others. It consistently under or overestimates the value you want to know. This is really important for an FRQ. If you are asked to describe how the design of a study leads to bias, you are expected to do two things. Number one, identify the problem. And number two, explain how this problem would lead to an under or an over estimate. So exactly what this did. Y'all see what I'm saying? Say why it's bad, and then say how that badness would affect your information. Let's see. Here's another one. Here's my favorite one. Donuts. Krispy Kreme versus Dunkin'. Do y'all have a preference? They're very different donuts, aren't they? Krispy Kreme is very light and fluffy and kind of melts in your mouth. Dunkin' Donuts are they're very cakey. They're very dense, right? A lot of people like those if they're going to dip them in coffee. Okay, so if I was going to do a survey and I have my little clipboard and I go stand right outside of Krispy Kreme. Hey, which donuts do you like? What's the problem with that? What kind of bias? Because I'm doing something that's convenient or something that I know is going to tip the scales one way or the other. What's this going to do? It's going to overestimate the percent of people who like Krispy Kreme over Dunkin' Donuts. Now, when I publish my data, when Lester Holt sits on the 6:30 national news, a study was done to compare Americans, whether they like Krispy Kreme or Dunkin' Donuts, was overwhelmingly in favor of Krispy Kreme. Does he say, oh, but by the way, they stood outside of Krispy Kreme donut to get this data? They don't say that. It's in there in the fine print somewhere. It has to be. But when they present that data, they can completely do a terrible sample that produces skewed data to make it say whatever they want it to say. Think about Democrats and Republicans. If I'm trying to make a story spin a certain way, and I want to go ask how Americans feel about it, I know exactly where I'm going to go and who I'm going to ask and how I'm going to ask them to get the data to say what I want it to say. All right. Voluntary response sample consists of people who choose themselves by responding to a general information. I'm going to sit at a table outside the cafeteria with a poster that says smiley fries or regular fries. And you can come up to me and cast your vote. That's voluntary response because you are volunteering your response. I didn't come ask you. Do y'all see the difference there? I'm not asking you. You have strong feelings. Oh, heck yeah, I love some smiley fries. Let me go tell them what I think. Or no, I hate the smiley fries. I like the regular fries. Let me go tell them what I think. But people who really don't care either way, they're not gonna mess with it. Voluntary response, you usually get people who are hardcore one way or the other, who are gonna volunteer their response. Here's an example. Call-in surveys, text-in surveys, write-in surveys, and internet polls. People who choose to participate in such surveys are usually not representative of some larger population of interest. Voluntary response samples attract people who feel strongly about an issue, and this leads to bias. Who has ever bought something on Amazon? Have you read the reviews? Have you read the super angry guy who was missing a piece that he couldn't put it together and oh my gosh, and this is crap and I would never, ever, ever? He's going to go and fill that out because he is ticked off that he had to put this thing together and he had to call customer service and he got somebody who didn't speak English and they didn't help him and oh my gosh, this was just a mess. So he got all kinds of fired up. He wanted somewhere to voice that. So he went to the reviews and put his in there. Now somebody whose entertainment center arrives perfectly, all the pieces are there, put it together, yes, it's wonderful, great, I'm moving on with my life. I'm not necessarily going to go and say, oh my gosh, this was amazing. Let me go tell everybody. A radio show invited their viewers to go online and vote on the question, would you be more or less likely to vote for a presidential candidate who supports giving driver's license to illegal aliens? The results, 97% of the 7,000 plus people who voted by the end of the show said less likely. What type of sample did the radio use, and explain how this sampling method could lead to bias in the poll results? So what kind of bad sampling that we've talked about is this using? Voluntary response. Write that down. Voluntary response. Explain how this sampling method could lead to bias in the poll results. Take 45 seconds and just write me a little sentence. Because this is one of those things where it's easy to think, but sometimes it's hard to write. All right, tell me what you're thinking. Who thinks they've got a good sentence? Or part of a good sentence? Or the start of a good sentence? What do you think, Katie? Mm-hmm. What else do you need to put in there? And what do you think it would do? Okay. And what was this from? Like where did these people hear about this information? On a radio station. There's some radio stations that support political parties. Yes. There are certain radio stations that swing in both directions, right? There are certain radio stations that swing in one direction or the other. So if I'm listening to that radio station, doesn't that probably mean that I have views like the people on that radio station? So if the guy is fired up about something, odds are I'm going to be fired up about it too because we have similar beliefs because I'm choosing to listen to him. So this is a crazy overestimate. Let's see. I have voluntary response sample. Those who voted were listeners of the radio program, which means that they are likely to think like the views of the station. Probably an overestimate of the percent. They are calling in because they feel passionate about something, or this is something that they feel very strongly about, but then they also agree with the views of this radio station. That's why they're listening to it. Very few people, well, I just really disagree with them. Let me listen to them all day. You don't. Nobody wants to do that. All right, identify the sampling method used, then explain how the sampling method could lead to bias. A farmer brings a juice company several crates of oranges each week. A company inspector looks at 10 oranges from the top of each crate before deciding whether to buy all the oranges. I got to vote for convenience. Do y'all agree? Absolutely. Let's write that down. Convenience. And what are you thinking? Identify the sampling method used. Okay, we've done that. It says, then explain how the sampling method could lead to bias. So why is this sampling method bad? What could it lead to? Absolutely. If I know he's going to just look at the top, I'm going to put my prettiest oranges on the top, and I could have crappy oranges on the bottom. So it could probably what? Overestimate the quality. Yeah, it could be an overestimate of the quality of oranges because he could be hiding his bad oranges underneath. So again, we're saying what it is, but then we're also saying what it's going to do to my data. The ABC program Nightline once asked whether the United Nations should continue to have its headquarters in the United States. Viewers were invited to call one telephone number to respond yes and another for no. There was a charge for calling either number. More than 186,000 callers responded, and 67% said no. Yeah, first of all, what kind of sample is this? This is voluntary response. Okay, talk to me. Okay, so this is ABC program Nightline. But it's asking you to call in if you like having United Nations in the United States or if you think it should be moved. If I'm happy with the way things are, am I going to be all up in arms about it? No. But if I think that's crap, if I think the United Nations should not have its headquarters in the United States, I think it should be somewhere else, am I going to call? So what do you think this is going to do? It's going to overestimate the no's. Happy people don't usually stand on soapboxes. Do y'all know what that means, stand on your soapbox? They used to, way back in the day, they would have like town squares, and you would get like a soapbox, which was literally a box that soap came in, and they would stand on top of it and voice their opinions and preach and talk about issues. They would stand up on this sort of like a stage. So when people say get up on your soapbox, it means you're about to go on a tirade. You're gonna preach. You're gonna give your opinion. So I'm not gonna stand up on my soapbox unless I really don't like what's going on. If I'm happy, I'm good. Okay, so now let's talk about how to sample well. Random sampling. Random sampling is using a chance process to determine which members of a population are included in a sample. The easiest way is to put names in a hat and draw names. A simple random sample, and guys, we're going to use simple random samples so much we're going to call it SRS. You can abbreviate it SRS on my homework, on my test, and on your AP exam. SRS is a simple random sample. So a simple random sample, and this definition is really, really important. Hint, hint, nudge, nudge, wink, wink. Okay, a simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance of being selected as the sample. Every single group of n individuals in the population has an equal chance to be selected as the sample, okay? And this is me interpreting that. It gives every possible sample of the desired size an equal chance to be chosen, and it gives each member of the population an equal chance to be included in the sample. It's going to pop up on your multiple choice. So just be careful. Watch out for those on your homework and on your test review. The principal at South Stokes High School wants student input about limiting access to certain internet sites on school computers. He asked the AP Stats teacher to select a representative sample of 10 students. Ms. Patterson decides to take a simple random sample from the 750 students enrolled this year. She gets an alphabetical roster from the guidance office and numbers the students from 1 to 750. Then Ms. Patterson used a random number generator to choose 10 distinct numbers between 1 and 750. What does distinct mean? Say it again. What? So what does distinct mean? Yeah, I've already assigned them. If it's a random number generator, then it's going to just spit out random numbers, right? So what does distinct mean? Mm-mm. It's random. Technically, you could get, how many am I doing? 10? I could get 1 through 10. Technically, even though it's random, that could happen. Distinct means that they have to be different. I can't choose person number 25 and then choose person number 25 again. Distinct just means that they're different. I'm going to add another word in here. Is it valid or V-A-L-I-D? Which one is it? Oh, valid. What does valid mean? So what would be a number that's not acceptable? 751. So these numbers have to be valid and distinct. Valid, they have to be within 1 and 750, and distinct meaning they can't repeat. Okay, let's go to lunch. We'll come back and finish. Okay, so we talked about valid and distinct. Valid means it has to be in between 1 and 750. Distinct means they can't repeat. So we're going to use a random number generator to obtain n different integers from 1 to n. So your calculator does this for you. I don't think you're going to ever need to do it, but if you go under math, you want to try this real quick? Go under math and then PRB for probability. And then rand int stands for random integer. and then you just set your boundaries from 1 to 750. If you hit enter, it'll give you a random number. If you hit enter again, it'll give you another random number. What's in? It's above the 7 or the 8. Oh, we all have the same program. So by random, it will randomly select them, but all of your calculators are programmed with the same random integer program. So it's going to produce us all the same, which is... All right. Your N is your total number, I think. So from 1 to 750. N, yeah, skip the N. There you go. Okay. So here's the problem with that. You can't set up an FRQ and have you guys pick random integers because we'll all get different answers. So if you don't have access to technology or you're doing it and you want all of them to be the same, we're going to use, this is called a random number table. These are not your numbers. This is just the line. But and they're just gaps here because our brain does better in 5-digit chunks. So like this is 38448487889. Like these are it's just a string of random numbers, and you go all the way across the table, and then you'd go all the way over here, and then you'd come here. So if I need numbers from 1 to 750, how many digits am I going to chop off at a time? 3 digits, because I'm from 1 to 750. So how would I get the number like 2? It would have to be 002. Does that make sense? Okay, hold on. So like this one right here, this would be 384. This would be 484. This would be 878, which is bigger, so it's not valid, so I don't want it. This would be 918. That's too big. I'm only going to 750, so that's the valid part. 338, 246. Like, look at this one. There would be 46. Here would be 003. Do y'all see what I'm saying? So I'm going in 3-digit chunks because my highest number is 3 digits long. Valid means I can only be between 1 and 750, and distinct means I can't have the same number twice. If I get the same number again, I kick it out, and I go to the next one. So here's what this is going to look like. The school newspaper is planning an article on family-friendly places to stay over spring break at a nearby beach town. The editors intend to call 4 randomly chosen hotels and ask about their amenities for families with children. They have an alphabetized list of all 28 hotels in town. So the first thing they did, alphabetize them. And the second thing they did, what did they do? What do you see beside each? Yeah, they assigned them a number. So they got them in alphabetical order, and then they assigned them a number 1 through 28. It says use a random number table to choose what's SRS stand for? A simple random sample of 4 hotels. So let's go to our random number table. Okay, I'm going to close my eyes, and I'm going to point to a number, and that's where we're going to start. Ready? All right, I'm starting right here. So, yep. They're going to give you a string to use on a particular problem, but this is what we're going to do if we're going to use the table. We're going to randomly pick a starting point. Now, how many digits do I want to choose at a time? 2, because I go from 1 to 28. So, tell me what we're going to use here. We're going to use numbers 31, Are we? He's not valid. We're not going to use 31 either. You're right. So no 31, no 42. What's next? 48, no. 3, that's a winner. What's next? 71, no. 65, no. 10, yes. 36, no. 22, yes. 53, no. 50, no. 49, no. 6. Do y'all see how I did that? Valid and distinct. I didn't have any repeaters there. Now, why did I stop at 4? I want a sample of 4 hotels. So that is a simple random sample. So I'm going to take numbers 3, 10, 22, and 6. 3, 10, 22, and 6. And those are the hotels that I'm going to call. I randomly selected them. The basic idea of sampling is straightforward. Take a simple random sample from the population and use your sample results to gain information about the population. So guys, what am I going to do with these 4 hotels? I'm going to ask them about their amenities for families with children. What is the point of this survey? Why am I doing this survey? What am I doing? I'm writing an article. So I'm going to write an article about where people should stay at a nearby beach town and say hotels offer amenities like this, this, and this. I really am only talking about these 4 hotels, but I'm not going to say that in my article. I'm going to generalize my sample to the population. This is my population. All the hotels in this nearby beach town. Unfortunately, it's usually difficult to get a simple random sample from the population of interest. Imagine trying to get a simple random sample of all the batteries produced one day at a factory. Or a simple random sample of all high school students, all U.S. high school students. How would you get an accurate list of the population from which to draw the sample? It can be very time-consuming to collect data from each individual that is randomly selected. So when you have this large population, you think about each individual battery that's produced at a warehouse in a day. Hundreds of thousands of batteries. I'm not going to label all of them 1 through 1,000,000 and something and then randomly pick 20 of them. I'm not going to go number every single high school student in the United States and randomly pick 100 of them. It's too much time on the front end. So here's an alternative. A stratified random sample. And here we are on the board. We're random. We're talking about strata. This is on that little sheet that I gave you. Start by classifying the population into groups of similar individuals called strata. Then choose a separate simple random sample in each stratum, which is singular for strata, and combine all these simple random samples to form the sample. This works best when the individuals within each stratum are similar to respect what's being measured. Okay, let's do an example. In a study of sleep habits on school nights, the population of students in a large high school might be divided into freshmen, sophomores, juniors, and seniors. Then a simple random sample are taken from each group and combined together. So I get all the freshmen together and I pick 20 of them. And then I get all the sophomores together and I pick 20 of them, and juniors and seniors. And then I take those 20 from each group and put them together. Would that very nicely represent the population of that high school? Because I'm getting some of each grade level, right? Y'all go with that? So what's their strata? Their grade. The strata is their grade. So the strata has to be something that they have in common. You're grouping them based on some sort of similarity. And then once I do that, I take a sprinkle of each group and put it all together, and that represents the mass. In a pre-election poll, a population of election districts might be divided into urban, suburban, and rural. Then a simple random sample taken from each group and combined. I combined the few that I picked from each group into one group. Simple random sample and a stratified random sampling are hard to use when populations are large and spread out over a wide area. This is when we want to use a method that selects groups of individuals that are near one another, like a zip code or an area code, city limits, school districts. These all put things physically close to each other. A cluster is that. A cluster classifies the population into groups of individuals that are located near each other. It's a cluster. Then you choose a simple random sample of the clusters. All individuals in the chosen cluster are included in the sample. Okay, tell me what we did for strata again, because let's make sure we have the difference here, because this is a great multiple choice question. What did I do for strata? Okay, but how did I get my groups? Yeah, so they got to have some sort of similarity. So this group's all got to be, I don't know, redheads, and this group's all got to be blondes, and this group's all got to be brunettes. And then what do I do? Now I got my groups. Now what do I do? How do I get my sample? Yes, it's exactly right. I take a random sample of the redheads, I take a random sample of the blondes, and I take a random sample of the brunettes, and then I put all those together. So I'm taking some from each group, so I have a nice cross section of all hair colors. A cluster says that I take people who are physically close together and group them that way. But when I take my sample, guys, look. All individuals in the chosen cluster are used. I want to know AP stat scores in Stokes County. What would be good clusters? West, south, north. Okay. So let's say I randomly choose south. Now what do I do? Do I randomly pick a sample of y'all? Exactly. I take you all. Everybody in the cluster that is chosen gets used. Does that make sense? It becomes like a mini population. Now, is that good? Is that a good representation of Stokes County? Do you think how you guys are going to do on this AP exam is a good representation of how everyone in this county is going to do on this AP exam? No, that's not a good sample for that particular piece of data. It is good for saving time and money. It's a good multiple choice question. Works well when the cluster looks like the population but on a smaller scale. That's a very powerful sentence. Let's do that one more time. A cluster works well when the clusters look like the population but on a smaller scale. If the students at South represented the students from Stokes County, then that's a good cluster. Why does that not work for AP Stat scores? Why is that not a good representation of Stokes County? Because what? So when would a cluster ever represent? Who would have different classes? What's that got to do with stats? What's the confounding factor here? Yeah. It's the teacher. It's the environment of the school. It's the teacher that you get. At West, they're getting a Forsyth Tech teacher. Here you've got me. a little high school teacher. North Stokes, I don't even think they offer it anymore. So one school does not represent the county very well. But there are situations where that can happen. That's what this sentence is saying. It would work well when the cluster looks like the population. That's not the case for AP scores in the county if you cluster by school. Here's an example. We have a very large high school, one very large high school. Principal wants 200 randomly selected students. So she does a cluster sample of homerooms. She gets 8 random homerooms with 25 students in them to make her sample of 200 students. Do you understand that that's a cluster and not a strata? What's your homeroom based on? Your grade and your last name and your alphabet, right? So if I put everybody in their homeroom, think about your homeroom. Do you have all academic levels in your homeroom? Do you have all ethnicities or a good range in your homeroom? Socioeconomic backgrounds in your homeroom? Homeroom is a great cross-section of a school. So I'm going to go homerooms. It's a cluster because they're together. They end up in the same room together. Not based on ability or anything like that. They just happen to end up together. I'm going to take 8 random homerooms, 25 kids each. I'm going to use everybody in each homeroom in those 8 homerooms, and that's going to give my sample of 200 students. Okay, this is a great example. Hopefully this will help clarify. Student council wants to conduct a survey during the first 5 minutes of an all-school assembly in the auditorium about the use of the school library. They would like to announce the results of the survey at the end of the assembly. So they're going to take the information they want to be able to produce the results of their information before the assembly leaves. The student council president asks your statistics class to help carry out the survey. There are 800 students present at the assembly. A map of the auditorium is shown. Note the students are seated by grade level, and the seats are numbered from 1 to 800. So let's look. 9th graders are 601 to 800. So 9th graders are all here in the back. Those are all your 9th graders. 11th graders are 201 to 400. So they're going to be in here in the middle somewhere. And then your 10th graders are 400, so they're going to be in here. And then your 12th graders are in the front. Okay. Describe how you would use your calculator to select 80 students to complete the survey with each of the following. I want a simple random sample, I want a stratified random sample, and I want a cluster. And I just want to talk about it. I need how many kids? I want 80 kids. They're in seats, their seats are numbered. How would you do a simple random sample? How? How are you going to select a number from 1 to 800? Say it again. You could do the random integer function on your calculator to select how many? 80. What do they need to be? What are those 2 words? Not varied. Valid and distinct. Valid means I only need 1 to 800. Don't give me 801. I don't have 801 kids. Valid and distinct, I can't use the same kid twice. So I can use the random integer button on my calculator to find 80 valid and distinct integers between 1 and 800. Can you write that sentence? I'm not asking you to write that sentence. I'm asking if you could. I would use the random integer function on my calculator to randomly select 80 valid and distinct integers from 1 to 800. And that would give me 80 kids. And that's completely random. Okay, strata. What about a stratified random sample? What does strata mean? Yeah, they got to have something in common. Okay, well, how are they sitting? Okay, so what does strata mean? I'm going to group them how? Okay, I'm going to group them by their grade level. So I'm going to take seats 601 to 800 and do what? You had it, and then you lost it at the end. Say the beginning part again. And how many kids would that give me? That's what I want. But then you said something about pick random ones out of the 20 to put together. And so like you selected twice. Do you see what I'm saying? Yeah, I want 20 from each grade level. So how would I do that? Be more specific. How do I get those 20? Yeah, I would pick 20 random seats in each group. And so that would give me 20 freshmen, 20 sophomores, 20 juniors, 20 seniors, and then put them all together to make my sample, my stratified sample. Does that make sense? Okay, I like it. What about cluster? Cluster has to do with what? Physically close together. But you want the cluster, like can I just take the first row? That's 20. Can I just take the first 4 rows? That'd be 20, 40, 60, 80. That only gives me seniors and juniors. Does that give me more than that? Does it just give me seniors? Yeah, it just gives me seniors. So is that good? They're sitting close together though. Okay, what's another way you could chop at this auditorium to get a good cross section? Yes. Take a column of seats. Okay, so to be more specific, how are you going to randomly pick a column? Okay, are they already numbered? 1 through 20. Take your first seats. Okay, how many are going to be in each column? What's 800 divided by 20? Would that be 40? So how many columns would I need? I need 2 columns. So I'm going to randomly select what? Yes, 2 valid and distinct numbers from 1 to 20. That's going to give me my column. Then I'm going to take everybody from that column and use them, because in a cluster, I use everybody in that cluster. Does that make sense? And that gives me a cross section that looks like the population, because I'm getting freshmen, sophomores, juniors, and seniors. Do y'all see that? So, but all right. So if I have 40 rows, so if I take a cross section, if I take like this guy and everybody behind him, if I take column number 5, that's going to give me 40 kids. Well, I want 80 kids total, so I need 2 of them. So let's say I pick another one, random one, and it's 12. So I have 40 in this cluster and 40 in that one, and that gives me my 80. All right, all of that is written out here. All of it. So there's your random, there's your strata, and there's your cluster. All written out in detail. And you can use the random integer, you can use a random number table, but it's all written out for you. Okay, so let's see how we're doing. It says describe how you would use a random number table to get a random sample of 50 people who had listed phone numbers in a phone book that had 7,500 people with listed numbers. Describe how you would use a random number table to get a random sample of 50 people who had phone numbers. Four digits. Okay, so let's say you get, I don't know, 271. Who does that go to? What have we not done yet? Yeah, we haven't numbered people yet, have we? Does that make sense? Let's say I get a random number. Let's say I get 425. Who is number 425? I haven't numbered my people yet. Are you with me? No? Yes? I need to know who number 425 is. So I have to take these numbers. I have to take each person in the phone book and I have to number them. Well, that's a pain in the butt. And then I'm going to pick, how big are my digits? 4 digits. So I'm going to pick 50 4-digit, for those words, valid and distinct, good, until I have 50 random people. Does that make sense? Do you understand that you have to number your people first? If you're going to randomly get a number, you got to know who that's assigned to. So you've got to number your people first. Oh, so you're going to go by their phone number. That would be fine. But okay, but let's you got a phone book. You randomly get a phone number. You're going to go through that entire phone book until you find that number. So yes, you could, but oh my gosh. Yeah, and numbering 1 through 7,500 isn't a picnic either, but I'd rather do that than search for that. Use a line from a random number table given below to identify the first 3 people in your sample. All right, here we go. How big of a chunk? 4. So I have 9445. Is he valid? No. Okay, then I'm right here. I have 6483. Do we have a winner? Okay, awesome. What's next? 9673. Yes or no? No. 73. That gets me to here. 7800. No. 6436. Winner? Yes. Next. 6436. I end right here. So 8664. Is he valid? No. That gets me to there. What's next? Is he valid? They are my 3 winners. I identified the first 3 people that I'm going to go pick. You see how important the word valid is? How would you use a random number table to get a random sample of 8 families from a subdivision? The subdivision contains 92 families. I want you to picture a neighborhood. This neighborhood has 92 houses in it. I need a sample of 8, and I want to randomly get them. What would you do? Number every house 1 to 92. Awesome. Done. What's next? So I'm going to use my random number table. because it says use your random number table. I'm going to use my random number table to find how many? 8 2-digit, what are my words? Valid and distinct numbers between 1 and 92. Okay, now I want you to use this string of numbers and find me the first 4. Yeah, it says identify the first 4. Valid and distinct. $66, $33, $3, and $26 are our winners. Everybody okay? Y'all good? Okay. Suppose you want to survey a sample of registered voters of Chicago regarding their opinions about a proposed increase in sales tax. Categorize the following sampling methods using stratified, cluster, convenience, or simple random. So I want you to read those 4 and see if you can categorize them. All right, what's A? Strata. What's your strata? The age. So guys, all right, so let's say, and make sure you understand this, I've got all my groups of all the different ages. Now, how do I collect my sample? So if I want 50 people and I got 5 age groups, I'm going to take a random sample of 10 from each age group and put all of them together. So I take a little bit from each strata. Select, because why, guys, why would it not make sense to take one whole strata and ignore all the others? Why does that not make sense? Yeah, what are these similar? How are these similar? Do you think that's going to affect their voting? Well, I don't know what we're voting. Sales tax? Absolutely. I don't want a group of people that are all the same. When I'm doing a sample, I want a cross section of my population. So taking a whole strata doesn't make sense. All right, B, what do we get? Cluster. Absolutely. Area codes. C, simple random sample, and D, convenience. Yes, and awful, right? Terrible convenience. Okay, this is another really good one. The manager of a sports arena wants to learn more about the financial status of the people who are attending an NBA basketball game. Now, have any of y'all ever been to an NBA basketball game? Have you watched an NBA game on TV or at least seen clips or something? Okay. What would you say about who sits where? hmm Or the celebrities, yeah. And where where would we sit? Why? Because the tickets are cheaper up there. Yes, absolutely. Okay, now look. The manager of a sports arena wants to learn more about the financial status about people who are attending an NBA basketball game. You guys just started talking about stratas. Okay. He would like to give a survey to a representative sample of the more than 20,000 fans in attendance. Ticket prices for the game vary a great deal. Seats near the court cost over $100 each, probably more than that, while seats in the top rows are $25 each. The arena is divided into 30 numbered sections from 101 to 130. So guys, a section is from top to bottom, from roof to floor. That's a section. Okay, each section has rows. Rows go this way. So A is nearest the court. We're up here in ZZ. So we could be in the same section with Drake. But we're going to be ZZ and Drake's going to be A. All right. Explain why it might be difficult to give the survey to a simple random sample of 200 fans. So I'm going to just randomly select seats. I could put them all, I could put everybody's ticket in a bowl and just select tickets. Why is that not efficient? Do what? It is a lot of tickets. 20,000 tickets. And I'm looking for 200, so it's a lot of tickets. What else? But if it's a simple random sample, does everybody have a chance to be selected? Right? If it's a simple random sample, everybody has an equal chance. Do all seat, if I did it by seats, if I wrote everyone's seat down on a sheet of paper and put it in a bowl and drew, there you go. Not all seats are filled up at games. You've got some empty seats. You've got people who bought tickets who didn't show. You've got tickets who didn't sell. Then what if I find that person? What if I figure out that seat and I go to that seat? Who's been to something, football, some sort of concert, something where you went and you were noticing these seats way down there and nobody was in them. And you keep looking and nobody's in them. You're like, hey, let's move. And you move to better seats, right? You are now no longer in the seat you bought a ticket for. So if my ticket gets drawn, I'm not there. I'm way down here. So people move around. What if I had to go potty and they come to my seat to give me this survey? I'm not in my seat. I went to go get a hot dog. I'm not in my seat anymore. Okay? So, I mean, it's not bad, but it's not, but that's why it could be difficult. Okay? Number 2, which would be a better way to take a stratified random sample of fans using the lettered rows or the number of sections? What do y'all think? Do y'all agree? Strata. Strata. Gotta have something in common. Do the sections all have something in common? The rows put you by strata. So if I'm going to go strata, do I want a section or do I want the rows? So my strata would be like front 2 rows, next 2 rows, then maybe the next 5 rows, and maybe the next 5, like that. I would slice it horizontally and go up because that's putting us, what's our strata? How much people paid for a ticket. You could say it's how much people love the game, but you could have people who really love the game who just can't afford to be that close to the floor. So, which would be a better way to take a stratified random sample of fans? We would definitely use the lettered rows. I would circle that or underline that so you can look back at that one if you need to. The lettered rows. That was 2. Which would be a better way to take a cluster? Rows or sections? So cluster means you want everybody kind of in the same area. Okay, but what I really want you to take away from a cluster, guys, a cluster is a good representation of the population. It is a slice of the population. And if I do a cluster, if I do a section, am I not getting a slice of cheap seats all the way down to the good seats? So that's a great representation of the whole population. All right, do y'all feel like you have a good idea of cluster and strata? Here's the problem. Let's see, what's today? Thursday? Sunday night, when you go to do your homework, you're going to have forgotten. So you need to make sure that you go back and remember what those are before you dive into your homework. Okay, inference. The purpose of a sample is to give us information about a larger population. The process of drawing conclusions about a population on the basis of sample data is called inferences because we infer information about the population from what we learned about the sample. Inference from data collected from a convenience sample or voluntary response sample would be misleading because they are biased. Does that make sense? Inference, if I project from what I learned about my sample, if I project that onto the population and my sample was either a voluntary response, super passionate people, or convenience, I stood outside Krispy Kreme, is that a good representation of the population? No, that's terrible. It's awful. That's why this is bad. Even from a random sample, results are not likely to be exact, but it should be close. The goal is to just be as close as possible. Larger random samples give better information about the population than smaller samples. By taking a very large sample, you can be confident that the sample results is very close to the truth about the population. If I wanted to know, I don't know, the average GPA of students at South Stokes High School, and I just went in the hallway and grabbed 5 kids, or I went in the hallway and grabbed 100 kids, which one would be a better representation of the population? So the bigger the sample size, the more accurate your conclusion is. Okay, what can go wrong? Undercoverage occurs when some members of the population can't be chosen in a sample. A sample surveys of households will miss who? Households. Homeless. Who else? Who does not live at home? College. Who else? Military. So that's under coverage. An opinion poll conducted by calling landline telephone numbers will miss what? Satisfied people. Yeah, people who don't have I don't have a landline. Do y'all have a landline? I don't. When we moved, we gave ours up. So if they're calling all the landlines, they're not going to reach me. That's under coverage, just because I don't have a landline. So is everybody clear on under coverage? I'm trying to reach you, but I can't because of the way I'm trying to reach you. Non-response. You've got to get voluntary response and non-response straight. Non-response occurs when an individual is chosen for the sample but can't be contacted or refuses to participate. I want to collect data. I give a survey out in homeroom. Is everybody going to fill that out and give it back to me? No, some people are just going to throw it away. But did I reach you? But you chose not to respond to me. That's non-response. You chose to not respond. What's voluntary response? That's when what? Right. Did I choose you? I didn't choose you. I just put it out there. You chose yourself to respond back to me. Non-response is I chose you, but you did not respond back to me. So make sure you have those straight. And that's what this is. Non-response can only occur after a sample has been selected. In a voluntary response sample, every individual has opted to take part. So there's not a non-response.
So could you use non-response as like the seat ticket thing also for like if you weren't in your seat?
Yeah. Yeah. All right, response bias. A systematic pattern of inaccurate answers in a survey. People lie about age, income, guys focus, drug use. They may misremember facts. They might make up an answer because they don't want to tell you the truth because they're embarrassed. People's responses can be affected by the interviewer's gender, race, age, ethnicity, or behavior. If I'm a 17-year-old girl and a hot 18-year-old boy comes and asks me a question, I'm going to say whatever he thinks I should say because he's cute. So my response is being affected by his gender. If someone comes up to me and throws crap at me and says, here, fill this out, oh my gosh, hurry up, is that going to affect my response? Absolutely. They've just ticked me off. It's going to affect my response. The wording of questions is the most important influence on answers given in a sample survey. Confusing or leading questions can introduce strong bias. This is really funny. Changes in wording can greatly affect a surveyor's outcome. Don't trust the results of a sample survey until you have read the exact questions that were asked. Watch this. Here's a survey with 2 questions. Do you think the order of these questions would alter their response? So here are the 2 questions. How happy are you with your life in general? How many dates do you have last month? So if I asked you the first question, I'm good. How many dates did you have last month? None. What if I asked you this? How many dates did you have last month? None. How happy are you with your life in general? I'm a loser. Oh my God. Right? So the order of these questions matter. They are going to influence me. Comment on each of the following as a potential sample survey question. Is the question clear? Is it slanted towards a desired response? Some cell phone users have developed brain cancer. Some cell phone users have developed brain cancer. Should all cell phones come with a warning label explaining the dangers of using cell phones? Like, what if you take that first sentence out and ask me the question? Do you think you'll get a different response? Guys, this is bias wording. I am trying to alter your response. Do you agree that a national system of health insurance should be favored because it would provide health insurance for everyone and it would reduce administrative costs? What's biased in that part? You should stop right there, or should be favored. Because everything after the word because is trying to sway you one way or the other. It's bias wording. In view of escalating environmental degradation and incipient resource depletion, would you favor economic incentives for recycling of resource-intensive consumer goods? Oh my word. Right here. That's too technically worded. You ask somebody that? You ask Joe Schmo that with that kind of vocabulary? What are they likely to do? Right. They don't want to admit that they don't know what that means. So they're going to say, yep. Yep. I do, very strongly. Yep, moving right along. They're going to walk away. They have no idea what you just said, but you're intimidating them with your words. Okay, check your understanding. Whew, perfect timing. Each of the following is a possible source of bias. Name the type of bias that could result. Undercoverage or non-response. Do A, B, and C really quick. This is undercoverage versus non-response. Okay, what's A? I got to vote for, would you say, which one? Non-response. What do we think? Nobody knows. I got to vote for non-response. All right, defend your answer. Someone may not be on it. Non-response means you asked me and I didn't respond to you. So if you can't reach me because I'm not in the phone book, that's not non-response, that's under coverage. A is under coverage. Do y'all see how these can get tricky? Some people cannot be contacted in 5 phone calls. You have tried to call me 5 times. I have not answered. That's non-response. You have contacted me. I have not responded to you. That's non-response. Interviewers choose people walking by on the sidewalk to interview. Why?
Because some people ride bikes, some people
Aren't on the sidewalk. Yeah, they're not there at that particular time. I'm in my car. I'm not on that sidewalk. That's under coverage. You're reaching people, but you're only reaching a very small piece of people. All right, let's see if we can get this last one in. A survey paid for by makers of disposable diapers found that 84% of the sample opposed banning disposable diapers. Here's the actual question. It's estimated that disposable diapers account for less than 2% of the trash in today's landfill. In contrast, beverage containers, third-class mail, and yard waste are estimated to account for about 21% of the trash in landfills. Given this, in your opinion, would it be fair to ban disposable diapers? Bias wording. What's it going to do? Yes and yes. So not only is it bias wording, but it's going to sway people to be in favor of disposable diapers. They don't want to ban them because you've just told me that it's not that big of a deal. So remember, when you do this, when you tell me what's bad about it, tell me which way it's going to sway. Okay? Okay. I spy in your future a quiz. We've covered a lot of vocabulary today, haven't we? I spy a vocab quiz on Monday. You have that sheet, right? You have that sheet. You know which ones are tricky and close together? Just pay attention when you're doing your homework. Okay?